So my name's Emily Blacklock. I'm a PhD candidate at the University of New Brunswick under Remy Rochette. And I'm going to be talking about my thesis on utilizing pop-up satellite archival tags to monitor migratory movements of adult American lobster in the Bay of Fundy and Gulf of Maine. So to start off talking about what I'm referring to with migration, I'm talking about the seasonal movements of animals from one region to another. Now, there's not all areas in fishing that lobsters are making these giant migrations. The Bay of Fundy is very specific with very large migrations. But it's important to note that not all lobsters migrate, even in the Bay of Fundy. With traditional fisher knowledge, we are aware that there are lobsters that aren't migrating. They're known as groundskeepers. There's not a lot of research on them right now, but there will be after all of my work is done. But it's important to understand migration for a variety of reasons. And as many of us know, because we are all lobster people, they're behavioral thermoregulators. They're going to the temperatures that they need to be at in the Bay of Fundy that have that ability because there's such a wide range of temperatures at all times. And temperature is very important, as you've heard in many other talks, for things like growth rate, sexual maturation, embryo development, and hatch. Now, due to the time that we have and the tags that I'm using, as you saw in the original picture, I'm talking about just the adults today. We can't use these tags on anything smaller than an adult legal lobster. Now, when we talk about Bay of Fundy migration, if you haven't seen it before, this is our map, and you can see some of our LFAs outlined on there, so all of our lobster fishing management areas. Lobsters are known to go to deeper waters for the fall for winter to avoid those drastic temperature changes in the shallow waters, and go to shallower waters in the spring for summer to get those warmer temperatures they need for molting and hatch. But how did we get to understanding this? A lot of it was done with tag and recapture methods. So these are used, and you've heard many talks about them. I think they're a wonderful method. They require a very large sample size, especially in the Bay of Fundy, where we have so many fishing areas. We're tagging as many lobsters as we can with these tags that have some contact information, whether it be a phone number or an email, and an identification number. So here you can actually see 3 of our Bay of Fundy tags. The blue one is from the University of New Brunswick. It's a T-bar tag. The red one from Southwest Lobster Science Society is a streamer tag. And the one from Grand Manan is a claw tag, which is a temperature logger attached right to the lobster. Now, these tags are all used, and they're fantastic, very large sample sizes, and that's because there has to be an active fishery present to catch these tagged lobsters and the ability to report them. They're already extremely hard to catch. It's about a 10 to 15% return rate in most studies that I've actually reviewed, and that's because you have to be able to find the lobster with the tag still attached, be able to read the tag, and be willing to report it. This may only give a few data points, but this is not to ever say that this data isn't valuable. This is an example many people have seen from Campbell, tagging lobsters right off of Grand Manan. This is one of many examples of maps. There was about 3,000 lobsters tagged off Grand Manan, which is where the circle is that says 1,700, because 1,700 of them were captured again in very close proximity to where they were tagged. And it really highlights the displacement the lobsters went and the range that they were able to cover for those that were tagged or caught farther off after being tagged, including the one tagged down this way about 322 kilometers from where it was originally tagged. That doesn't mean that lobster walked 322 kilometers. It means it at some point traveled that distance. And we really highlight the challenge with a few data points, and many people are in this room are from the US and may not know exactly where this is, but this is St. John, New Brunswick. And if I was to tag a lobster off of the port of St. John and to capture it sometime later with one of those tags, I might assume that it walked between those two distances, but that's its displacement. That doesn't mean it went that exact way. It could have gone many other places. And in the Bay of Fundy, having those 2 points can be missing a lot of data, especially if the lobster went somewhere down like Grand Manan. If it walked all the way through several fishing areas, we could be missing that data without any extra recaptures and missing a whole displacement path. It's a big challenge for us, especially when all of those fishing areas have different fishing seasons that may or may not overlap at different times of the year. And even then, we might be missing its entire migration pattern, even having only those 3 points. We might be missing things that it encountered environmental temperature differences, environmental factors, and anthropogenic disturbances it might encounter within the Bay of Fundy. So the solution to this is pop-up satellite archival tags, or PSATs. So these are tags that I brought one if anyone want to see it. They are quite large, but they've been made by Desert Star, the ones that we're using. The tag itself is able to collect data on depth, temperature, acceleration, and location. It does have a solar panel, so anytime it's at the surface, it can charge itself, so it doesn't need battery replacements. At the end is a release that has a programmed pop-off date. It allows the tag to pop off the animal when it's needed and float to the surface to transmit data based on the antenna that is missing on this one but is shown on the screen, as the buoy allows it to float. So these tags are great in this way, but they were originally designed for large pelagic animals that came to the surface like the sailfish. So these tags would be coming to the surface and would transmit periodic data. That also meant that they were able to encounter sunlight, and sunlight is the key thing to be able to use the location feature, which means I'm unable to use that location feature and have to rely on modeling. There are numerous benefits to these tags, the first one being that they're fisheries independent data collection. I don't need anyone to report the tags. I don't even need a fisher to be present in the area, so if we're trying to establish a new fishery, they would be a great source to use. There's fewer lobsters needed. I'm not hoping that I'm going to have someone recapture these lobsters. I'm likely to get data off all the tags if they're able to transmit when they do pop off. It's relatively continuous data collection. So in my case, it's set for every hour, but it could be even shorter time periods than that. And it provides the ability to reconstruct more accurate movement paths. To be very honest, there are some large drawbacks that I do need to highlight. They're expensive. You can buy one of these tags, or you could tag 5,000 lobsters with T-bar tags. There is a size limitation, so it does have to fit on the lobster. This lobster is 3.5 pounds. It's about 130 millimeters carapace length for any of you who don't do it by weight. They're large lobsters, but I need to be able to fit both brackets on the carapace itself. And there is some impacts on behavior, and everyone always asks to hold the tag and see how much it weighs. It's not the weight. There is a large float at the rear of the lobster that is buoyant. If you have interest, I chose not to share this data today just for the sake of this conference, and I had some other interesting data to show. If you want to hear about the behavior studies we've done, I do have all the data, and I know a few people have wanted to see some of the videos from it. But the objectives for my actual thesis are to reconstruct the movement tracks of adult lobster, both male, female, as well as buried female, for the fall shallow to deep migration and the spring deep to shallow migration, as well as to quantify connectivity among the management areas, both in Canada and the US, as well as the inshore and offshore populations, and to document the thermal and bathymetric histories of ovigerous female lobster and determine the location of hatch within the Bay of Fundy. So I broke this down into 3 different times that I went tagging, and this is all very much based on our fishers. We did do this based off the catch that they were getting at the time, so it's based on when our seasons start. The first was tagging males and females in October and November as soon as the seasons opened in the different lobster fishing areas. We also tagged ovigerous and non-ovigerous females at the mouth of the Bay of Fundy, still in 3 different fishing areas, to try to get their migration back in after January, back to shallow waters. And I tagged ovigerous females in June. That way I was able to take egg samples and predict when those eggs would hatch and then match that along to the tracks that they moved. Now at this point you're still wondering how I got these on the lobsters. So for the tagging, the data I said was every hour on depth and temperature. The release date of the tags when it pops off is programmed, so it was set to be on August 10th, which in our case is before the lobster molt, so they wouldn't go under a rock and get my tag stuck, but after when the eggs should be hatching based on all the work in our lab. And it's attached to the carapace using 3D printed brackets that are modified to hold the tag since they were originally meant to be harpooned into fish, as well as glue and epoxy. So at this point you're like, what are these tags even giving us? So this was an example of one of the males I tagged December 6th of 2022 at the Wolves Island, which is an LFA 36 in the Bay of Fundy, the green dot there. And this lobster was found later with the tag released June 11th of 2023 down by Graham and Ann, which is a different LFA, LFA 38. So the displacement between those 2 locations is 37.5 kilometers. Now this is before any of the modeling has been done. That's just a straight line. It started in one spot and had to end up in the other. But then we can look at the actual data from the tags. So we get depth and temperature from all of these tags. As you can see here, this lobster started just shy of 100 meters at 12 degrees and went down to deeper than 150 meters at 8 degrees. So we get trends like this for all of the lobsters we tagged. Some are more drastic than this one, but this was a nice simple one to show. It went to a different location and we can see that change. But what are we going to do with that data? Because my whole point of mine is connectivity and where that lobster went. So we want the most likely movement path, and this is where it gets a little bit into modeling and a little bit complicated. What we're going to do is take the Bay of Fundy and put a grid over top of it, almost like a chessboard. On top of that grid, we're going to put a temperature model domain that's been validated for the bay, meaning at any point I could put my finger on one of those chess squares and say at any date and know exactly what temperature it was on the bottom, as well as a depth model domain, so we know exactly the depth of all of those grids. Then, just like chess, we add some rules like model constraints of how far a lobster could walk in a day. Then on that grid, we find the first spot, which is where I know I put the lobster back in the water with that tag, and the location the tag popped off at, and that's our start and our finish. Then to join those two, we start making paths, and we get thousands of these paths, but you start at point A, and what's the next grid you could move to get the right temperature and depth based on the tag data. And we do this over and over again and get thousands of them, and then have to figure out which is most likely. And thankfully, with all the collaboration we have a lot of validation points because these lobsters liked getting free meals out of the traps, and they got caught a lot. So then we can figure out those validation points. I tried to have a really cool model to show all of you. It is not done to the level I want it to be. We'll still look at that one in a little bit, but this is an example of the pilot study done by Bjorkstead and Hanley in 2017. They tagged 2 lobsters in Graham and Ann. If you see the depth and temperature profiles, one is shown in black and one is shown in red. And here's the model they created for the one that is shown in red, starting in Graham and Ann where it shows the red dots, and moving up the coast of Nova Scotia where the purple ones are. And if you look closely, you see lots of gray options there, other lines, and those were ruled to be not the most likely. Now I did try really, really hard to get a super cool lobster to make the symposium make sense. And it's not done, but we're still going to talk about it anyway because it's kind of cool. So this is a lobster that I tagged in Nova Scotia, and it ended up in Portland. So just like the symposium, a great collaboration of this lobster. And it was large enough that once it got down to Maine waters, I believe it was safe and could not be kept. So very smart lobster. So again, we do have a depth and temperature profile for it. And because my model's not done, it is still running. It only has a few hours left, but not in time for this presentation, of course. I actually made my own grid on top of the Bay of Fundy. This is based solely on depth. I couldn't do temperature and time for this. You can see the green square where the lobster started and the red square where it ended. All the yellow squares are the ones it possibly could have walked through. So everything else is either too deep or too shallow. And based on that, you can start to see there's kind of a spot where it obviously had to transition across and then move down the coast for where the tag popped off. So even the lobsters are coming down this way as well. And although I only have this one partially done, the next time we meet, hopefully I have a better model for it. And I actually have quite a few lobsters that came down to Maine. But this is the most detailed data to date on several aspects of the movement of adult American lobster in the Bay of Fundy, especially when it will be fully completed. It has some very large implications, especially for lobster biology and our understanding of how lobsters are using the bay and how they're utilizing different temperatures. Potential effects of climate change that could be influencing it, especially how they're utilizing different temperatures. Hatch locations and regulations. A lot of what we do in the Bay of Fundy, especially in our lab, is looking at when eggs are predicted to hatch. But understanding the locations can be very ideal, especially since marine protected areas are starting to become a bigger notion in the Bay of Fundy. If we can protect the areas where they're hatching, that could be important. And there is possible implications for fisheries management. But this is the first use of PSATs to this scale. So I used 106. That is a lot. It's a very big study. The original pilot only used 2. And the size difference is noticeable. So the original pilot study was based off diving, and they dove for their lobsters and selected 2 lobsters of 140 millimeters. I didn't have that choice. I was on the boats when they were actively working, so I chose what I could. I range from 95 to 130 millimeters, so they are significantly smaller in some cases. And it really highlighted the challenges, the first being those tags are buoyant. They do cause lift. Again, if you want to see that data, I think it's super great, but the next time we meet, that'll probably be presented. And the tags don't always operate as expected. I want to say they're the greatest tags ever made. They're not. I deployed 106 tags. 78 of those were able to communicate with satellites. That doesn't mean it was good data. I had a few lobsters at negative 700 degrees. These tags have some quirks that still need figured out. I had 65 of those tags that gave pop-up locations. So when they came up, they said exactly where they were, and I validated that that is exactly where they were. I only had 71 tags with usable data, and that number isn't the same as the rest, and it's kind of confusing. Those 71 did not come from those 78 tags. So there was quite a few tags that were found on the beach by lovely beachcombers that had beautiful data that never ever connected to satellites, and I didn't know they even existed. So we had some issues like that, and a few other with pop-up locations. Fishers would land them with the trap. They were sticking out of the back of the trap, and when I dropped it, they broke off the lobster. So I don't want to ever discount these tags. The concept is great. As technology progresses and they get slightly smaller, and they might work a little bit better. I would like to acknowledge my supervisor, Dr. Remy Rochette and Dr. Eric Bjorkstead, as well as everyone who helped with these projects, especially Coldwater Lobster Association, Fundy North Fishermen's Association, Maritime Fishermen's Union, and Grand Manan Fishermen's Union. And since this is all about collaboration, this is, I hope, the list of all the fishers who have helped with this project. They've been great. They've taken me on boats, helped me find lobsters, taken lobsters back out when I've not been able to get them out myself, put out temperature moorings. They're the reason this entire project was possible, and I cannot thank them enough. Thank you.
That was really cool. Thank you for the presentation. Curious, I've talked with Remy off and on about the monitoring of temperature Bay of Fundy using the monitoring, you're using the mooring suite to try to capture Bay of Fundy. What model are you using to try to capture bottom temperature, not just the Bay of Fundy, but the entire Gulf of Maine?
So models have been a little bit tricky for us. Remy may have told you we were already making our own, and we actually put moorings out, and we lost every single one of them, because that's how the Bay of Fundy works. Mark Trudell has just placed an entire array of acoustic receivers. I believe it's every 4 kilometers as a grid, which have temperature, which we can use to validate. And one of my chapters was going to be to validate FVCOM. We switched to NECOFS, and the Department of Fisheries and Oceans Canada has now produced their own. So we're just going to use that one.
Oh, thank you.
Yeah.
Thanks, that was a really cool talk. I'm excited to see the data next time, especially the behavioral stuff. I just had a question. It was about, so you mentioned that fishermen are pulling up these lobsters and traps, and then, you know, that's how you are validating some of their locations. I guess I'm curious about the process for that, and I guess the outreach component, if there were any issues with kind of having these lobsters get caught in traps and getting them reported and not brought in. And yeah, I guess if you could just share some of the information on that.
Yeah, so our outreach is huge. I'm already very involved in the fishing community. I also fish, which has probably helped quite a bit. And because it was broad through all the LFAs, it was also a bit of a challenge. So there was a lot of CBC interviews immediately, trying to get out there what these tags were and exactly what to do. It was all over all of their Facebook groups. I went through all of the fishing associations. Thankfully, every fisher who actually caught one was somebody I knew. So it wasn't, or they knew somebody who knew me or knew that I had been tagging, so there was that bit of outreach. All the tags are labeled with my cell phone number, which is a mistake. If anyone ever does a science project, don't use your personal cell phone number. But because they're so weird and strange, if I wasn't called immediately, there was a Facebook photo on one of the groups laughing at it. And that immediately got back to me. Even if they didn't report a location, it actually pings when it hits the surface, so I knew where it was, which was also great. But they were really, really good at communicating about them. It was almost a goal to catch them. There was also a very large reward for sending a video of you putting it back in the water.
With your model and the extreme tides you have in that area, were you able to see those tidal sequences in the depths because they're on the bottom and therefore could use that to help say this is where they're going as well?
We do have that ability, but we're not going to use that data. This is actually quite a bit of data, and these tags are massive, so they're starting some of them in October all the way till August. So we can see it, but we actually remove that to allow it to match with the models of depth.